The Riddle of the Earth, Chapter 9, The Mission of a Comet, Comets and their Presumed Orbits. Comets are presumed to possess definite orbits which are calculated from the direction of their apparent motion. This theory, sustained by Halley in relation to the comet bearing his name, or I should say Halley really, is proving to be illusionary, for some comets do not return at all, like Biela's comet. Others arrive erratically, either early or late, and others whose orbits are estimated to require some phenomenal period of time, even as much as 100,000 years, may return in quite a short time. As to the latter class, there is a conjectural belief that the comets of 1880 and 1887 were one and the same, as also the comets of 1882, 1889, and perhaps Brooks' comet of 1893. When the career of a comet before and after attaining perihelion be taken into consideration, it can be seen that no orbit is possible. In its approach towards the Sun's corona, the nucleus is subjected to a powerful tidal strain and exposed to tremendous electrical energy, which produces a considerable disintegrating effect. Before the solar contact has occurred and subsequent to it, the continued redirection of the nucleus to gases, whereby the solid particles are fused and driven into the tail, must affect the weight and consequently any gravity which it might appear to possess. But if a body has no gravity, since at every moment it is wasting its own substance, it is evident that every moment it is wasting its own it is evident that it cannot possess an orbit. Howe remarks that a periodic comet moving in an ellipse, quote, loses substance at each perihelion passage and, quote, must be wasted away in time. It is an obvious truth, but this author understates the problem. It cannot move in any sustained elliptical orbit or in any consistent orbit, although it may appear to do so, for the reason stated, that there can be no geometrical figure to represent a body whose weight and consequently gravity is rapidly decreasing at each instant. Comets appear to possess orbits because they approach the Sun in one of three curves: A, an ellipse; B, a parabola; or C, a hyperbola. An ellipse is a closed curve, an oblong. A parabola, which most comets are deemed to follow, is a wider ellipse but unclosed at one end, in other words, the half of a wide oval. And hyperbola, more rare, is a slight curve which gives no indication of any orbit. In regard to these curves forming in various degrees an alleged orbit, it needs to be said that if the Sun were stationary, a comet drawn towards it would follow a straight line, but as both are moving, it comes up along a parabolic line and whisks off momentarily along the same curve, induced by its momentum, until the pull of gravity checks it and brings it round. If, therefore, a comet is performing an apparent parabola, it must be reduced to an ellipse, and should it once again survive the strain of a perihelion passage, it must shorten that ellipse in consonance with the laws of gravity in proportion to its weight, until at length it is irrevocably consumed. Such records as exist do not indicate anything but a short period for any comet after a perihelion contact. If a comet should possibly sustain an orbit extending to hundreds, to say nothing of thousands of years, the very rapid motion of these bodies would cause them to traverse other solar systems other than ours, and it remains for those who advance so grotesque a theory to explain why, when beyond the attractive forces of our system, they should return. A well-known geometrician, Mr. C. L. Poor, has said that a parabolic orbit is a geometrical impossibility. He points out that a cometary body would not pursue a parabola for an instant, because attracted by Jupiter or some other planet, its speed must be increased or decreased, which is impossible as a parabolic body cannot vary its rate of movement, or it ceases to be a parabola. Yet to explain this so-called parabolic orbit, theorists have conjured up a situation in which a comet, as it passes beyond the attraction of the Sun, becomes moribund until Jupiter or some other body takes pity upon it. As a cometary body, by reason of its sustained and continued loss of weight, cannot maintain a parabolic orbit, neither also can it continue along a hyperbolic course, for in either case the Sun's attraction must react upon it at a certain distance, taking velocity and weight into consideration, check its momentum, and bring it into the order of a temporary ellipse. It will be said that the so-called periodic comets, such as Halley's, Encke's, and formerly Biela's, prove that comets can and do possess orbits more or less regular and consistent, but such a contention cannot be sustained. The fact that a comet of a certain family appears more or less regularly is no proof that it is the same individual body, and the explanation of this is that comets are projected into the solar system in certain cycles, as also that they, having been once projected into it, circumscribe temporary orbits of short periods. There is also the general consideration of these strange orbits of both periodic and long-distance comets to be examined. The three types of orbit defined by astronomers, namely the ellipse, parabola, and hyperbola, are on the face of it entirely opposed to the laws of gravity. Satellites of the Sun, like our Earth, maintain an equilibrium based on gravity at a certain distance from their great luminary, the Sun being the axis of an enormous wheel round which all the various planets, major and minor, revolve in obedience to this same law of gravity. The comet, however, even of the short periodic type, approaches the Sun not only along an extended ellipse, but the Sun forms the apex and not the axis of this ellipse. Should the approach of a comet be in the form of a parabola, it is even more pronouncedly the apex, the headstone. It might almost be said of a pyramid. The case of the comet of 1882, which swung round 80 degrees of its ellipse within 3 hours, demonstrates quite plainly that such an orbit is one which cannot be pursued with any consistency, as it utterly defies the laws of gravity. Any elongated ellipse with the Sun at or near the apex as is an impossible hypothesis to any continuity, and hence no comet can be other than transitory.